Alright guys, welcome to another video. This time it is 2.7, solving systems by elimination. So here's our learning targets for today. And so this is the last of the three methods that we are going to use for the ACT. Alright, so what is the elimination method? The elimination method for solving systems of equations is also called the addition method. To solve a system of equations by elimination, we transform the system such that one variable cancels out. So if we look at this system of equations here, 2x plus 3y equals 15, and x minus 3y equals 3, if we add them together, okay, we can see that these red variables here are going to cancel out, and we're left with 3x plus 0 equals 18. All right, well, now that the y's have canceled out, we are allowed definitely to solve this simple 3x equals 18 formula equation to find x. Once we find x, we can plug it into one of the equations here and find y. So step-by-step process for elimination. You want to look for variables that are equal but opposite so that you can easily cancel them. If it's necessary, okay, you're going to multiply by one of the equations by a constant, a coefficient, in order to make one of the variables able to be canceled. So sometimes systems are going to have aren't going to have any equal or opposite variables, or they're not going to have any ones that are equal at all. So you have to multiply by coefficients in order to cause one of those to be equal, and then you can start canceling. And then so you're going to solve for one of the variables and substitute that back into one of the equations to solve for the other. All right, so let's take a look at this example here. All right, it's color-coded. It's kind of nice for us. All right, this is a pretty simple one. We're going to combine these. So we are going to say add them together. The plus and the minus, we're just going to combine these, add them together. So 2y plus 5y is 7y. The 7y plus negative 7, or 7x, excuse me, plus negative 7x gives me 0x. And negative 5 plus 12 is positive 7. So 0x cancels out. It's exactly what I want to happen. So I get 7y equals 7, and then dividing by 7, I get y is equal to 1. All right, so I'm going to pick one of these two equations, doesn't matter which, and I'm going to replace y with 1. So I'm going to pick I'm just going to pick the top one. Why not? So 2 times 1, because 2y, plus 7x equals negative 5. All right, so we get 2 plus 7x is equal to negative 5. I'm going to subtract 2 from both sides. So I get 7x equals negative 7. And then I'm going to divide by 7 to get x is equal to negative 1. And with that, I have my x coordinate, I have my y coordinate, so I'm going to write my x coordinate first, negative 1, comma 1. And we have solved this system. So what if the coefficients aren't opposite? We're going to solve the system using elimination. Still possible. So this is what I was talking about. We're going to subtract, okay? So instead of adding these together, we're going to subtract them. So I'm going to put a big minus sign out front to remind myself that I'm going to be subtracting these. Okay, so 4x take away negative 16x. Okay, so 4 minus negative. I remember that minus negative, so is its addition. So 4x plus 16x is going to give me 20x. Good start. 8y minus 8y gives me the 0y that I want to happen through elimination. And 20 take away negative 120 is 140 because we're going to end up adding those two. All right. The 0y is going to cancel out, so I just get 20x. Ooh, excuse my 2 there. Let me fix that. I get 20x equals 140. So dividing everything by 20, I get x equals 7. So I'm going to take the 7 and I'm going to plug it into one of the two equations. I think I'm going to go up and do the top one. So I know that x is 7, so I'm going to do 4 times 7 plus 8y equals 20. Oh my goodness, hang on, I'm gonna redo that last part. Yeah, the 20 I misclicked. All right, a little better, not the greatest, but better. All right, so I get 28 plus 8y is equal to 20. So subtracting 28 from both sides, I get 8y is equal to negative 8. And so dividing by 8 on both sides, y is going to be equal to negative 1. So my final answer, once I've done my elimination and then substituted that value in, is going to be 7 comma negative 1. All right, so take a look at this one. None of these are able to be solved by simple adding or subtracting. What do you think we could do to solve these? Well, give you a second to think about it. If I look at, okay, I can multiply negative 3 times 2, and then it becomes 6. But the only way I can do that is if I take the entire thing here and multiply everything by 2. So when I do so, okay, I'm gonna slot that equation below. I'm gonna slot it down here below. Okay, when I do so, I get negative 10x because you have to multiply. It's kind of like a super distribution property. I have to multiply everything by 2. So I get negative 10x minus 6y, excuse me, and then negative 8 times 2, so it's equal to negative 16. Okay, so now I'm going to focus on these two bottom equations here. So we're not doing the top anymore. We're doing these two bottom equations. This and this are opposites of plus minus, so I'm going to be using addition here, all right? So addition because they're opposite of each other. So negative 7x plus negative 10x. So that's negative 17x. And then these are going to cancel, so I get 0y, which is exactly what I want. It's the elimination method. And negative 1 plus negative 16 is negative 17. So with that, I can see that I'm going to get negative 17x equals negative 17. If I divide both sides by negative 17, I get x equals 1. So now that I have x, I can take it and put it into either one of these two equations. The original ones, of course. I think I'm going to plug it into the bottom one. So if I do that, I get negative 7 multiplied by 1 plus 6y equals negative 1. Fix my numbers here. All right, so I get negative 7 plus 6y equals negative 1. Adding 7 to both sides, I get 6y equals 6. Dividing by 6 on both sides, I get y is equal to 1. So the answer I get for this one is 1, comma 1. All right, and that's it. That's basically elimination in a nutshell. I do want to caution you, there is another harder type of this where you have to multiply both the top equation and the bottom equation by a coefficient in order to make one of the variables able to be canceled. So we may have to search for the least common multiple. So that's going to be something we're going to have to consider, the least common multiple, in order to sometimes activate the elimination portion of it. We're going to be using the least common multiple principle in order to find two variables that are able to be canceled out on each other. So just be aware that that is possible. We might have to multiply this top one by something and the bottom one by something as well. Just be aware those kinds of problems exist. They are a little more difficult, but totally doable, because once you get them down to that level of you've multiplied them both by the two coefficients and you've matched them up and eliminated them, they fall into place pretty quickly. So that's elimination in a nutshell for you guys. Thanks for watching, and I'll see you in the next video.